Hi guys, it's your friendly neighborhood physics teacher. Okay, so I just wanted to quickly go through some of the things that we covered in class with the big five equations. Hopefully the music in the background is calming and not too loud. So remember today that we talked about uniform motion, and uniform motion happens when our acceleration is 0. That's why there's no acceleration in this equation. So in this equation, our velocity equals our displacement over time, which is what we've been using up until this point. And then we also talked about what we do when we have acceleration. So when acceleration is not 0. And when acceleration isn't 0, then we have what we call the big five equations. And the way that they're laid out in the slides is a little bit different than in the textbook, because in the slides, I've placed them so that you have all of your displacement equations on the left-hand side and all of your velocity equations on the right-hand side. Now, remember that any of these equations, it is fair game to pick them out and solve for any of the variables that are in them. So for example, let's just say in this second equation, I have displacement, I have velocity and time, and then I also have acceleration here. And let's just say I actually needed to find acceleration. It's perfectly okay for me to substitute my values for displacement, velocity, and time into my equation and then rearrange it so I can isolate for A. And we saw this actually in this practice problem. So in this practice problem, it says a sailboat accelerates uniformly from 6 meters per second north to 8 meters per second north at a rate of 0.5 meters per second squared north. What is the displacement of the boat? So now I want to know what the actual displacement is. So to do this, I'm going to set up my equation on my whiteboard. I already wrote some things ahead of time because it takes me a long time to write. And I'm saying that my initial velocity, my V1, is 6 meters per second. My V2 is 8 meters per second. And my acceleration is 0.5 meters per second squared. And I want to know what my displacement is. So I'm going to look at all of my equations here. And I need to pick equations that have those variables inside of them. So I need something that has a displacement. I need something that has a V1, a V2, and an acceleration. So remember though that I don't have time. So any of these equations, like any of them that have a t in them, I can't use them because I don't have any given value for t. So if I'm looking here, I can't use that first one because it has time. I can't use the second one. It also has a t. So does the third one. And so does this fourth one. So really that just leaves the last one in my big five. So I'm going to look at here and I'm going to now rewrite my equation. So I have my V final, or I guess I should keep it as a V2. So I have my V2 equals my V1, and these were squared, plus 2AD. Okay, and again, I got these equations from my slides here, or from my textbook, or from the equation sheet that you will be given, and I'm picking the equation that has the 4 variables or 3 variables that I need, and I'm just omitting or getting rid of any of the equations that have the variables that I can't use. So in this case, I couldn't use t, so any of the equations that had time in them, I can't use, which just left this last one. So now I have my equation. I'm going to begin by substituting my values in here. So I'm going to substitute 8. I'm going to square it. I'm going to substitute 6. I'm also going to square it. I hope you guys are enjoying this epic mouse writing. And then I'm going to substitute in my 0.5 for my A. And it doesn't get squared. And then I'm left with D. And it's okay that I'm left with one thing because that's what I'm looking for. All right. So again, I'm looking for D here. That's what I want. So it's going to stay for a second. Okay. So I'm going to do all of the math things that I can actually do. I'm going to simplify this at this step as much as possible. So I'm actually going to do 8 squared in my calculator or in my head. And that's 64. I don't know why now we're using red. It's fine. And then I'm going to do 6 squared in my calculator in my head. And that's going to be 36. I'm also now going to do 2 times 0.5. That's 1. And I'm left with my D. And you could also rewrite this so that it's 64 equals 36 plus D. That's fine. Now, we want to figure out what the displacement is. So our goal here is to get D by itself. And if you recall from grade 9, 10, or 11 math, in order to isolate a variable to get it by itself, I need to do the opposite operation. So there's adding happening between 36 and D. I need to do the opposite, which is subtraction. And that's going to move it across the equal sign. So now I'm going to do 64 minus 36. And that equals D. So again, all I've done here is used my equation, I've substituted in my values, and then used a calculator in my head to kind of just do these simple math operations like squaring. I'm going to do 64 minus 36, and you get 28. And I'm just going to double check what my units should be. Taking a quick look back up at the question here, I have meters per second and meters per second squared. I know I'm looking for displacement, which is usually kind of a distance. So I know it's going to be meters. And I'm double checking here. I notice that everything is in the north direction. So then this is also going to be, we're going to get Christmassy before we get Halloweeny. I'm sorry, that was an accident, in the north direction. So my displacement here is going to be, that should be a D, is going to be 28 meters north. Okay. So that's the first question, the first practice problem there in that set. Hopefully this helped. I will post the next ones really shortly.